Hi, everybody. Thanks for joining us today for our webinar on smart manufacturing and cybersecurity in Industry 4.0. We have some terrific content today, and I'd like to make sure that everybody notes that we will be taking questions during and at the end of the webinar. So if you have any questions, please type them into the Q&A box as part of the webinar platform. And we'll either get to them real time or get to them towards the end of the webinar. Thanks again. And without further delay, I'd like to introduce Steve Roesing, President and CEO of ASMGi. Steve, take it away.
Hi, all. Thanks, Paul. Thank you all for sharing your time with us today. Looks like I'm muted.
You're good, Steve. You're good.
Okay. Anyway, we have a great topic today. So today's webinar is about Industry 4.0 or smart manufacturing, and it's a great topic. So I get started. I'm Steve Roesing, CEO of ASMGi. ASMGi is what I always call a full stack technology company, and by that what I mean is, like, we have IT and IT services, and the consultative side of security, which is GRC and cybersecurity operations, and software development, mostly on a lifecycle perspective. In other words, we outsource software development as well, but we manage it very, very closely. We're very familiar with the concepts and the processes involved in those things. One of the areas that we're really moving up the food chain now, and is moving up the food chain, is device level security, and that's what today's conversation is about. So in any event, so what are we going to talk about today? I think we're going to do some introductions and give you a little overview and some background on the topic, and we're going to talk about trends with devices and device level security specifically, and then we'll open it up for some questions. And I will make the comment that, you know, our goal is always to keep it as interactive as possible. And if you have questions, like Paul said, just enter them in the Q&A box, and we'll get to them, and we'll have a discussion about that. So Industry 4.0, smart manufacturing. Where did that term come from? Anyway, the industrial, it came from industrial revolutions, right? There have been 4 of them so far, and you know, you can look at Industry 1.0, 2.0, 3.0, and 4.0, and the years associated with those. When I look at this side, like, I notice a very specific thing, and does anybody else notice anything about this slide? The years between Industry 1.0 and 2.0, there's about roughly 100 years. Between Industry 2.0 and Industry 3.0, there's roughly 100 years. Between Industry 3.0 and 4.0, there's 50 years. So I equate that to the rate of change, right? The rate of change is increasing. And I think it's important to note that. So this 4th industrial revolution that we're seeing is related to technology and leveraging data. And those kind of things. So, and we think it's going to make a market improvement on manufacturing, the manufacturing processes in general. So when you think about this, like, what other, or how has devices and technology changed for the same years as the industrial revolutions? And like, what I always equate is, when I was in college, this was back in the 80s, I worked at LTV Steel. That company doesn't even exist anymore today. But the one of the projects that I was on, we put in a Bailey Net 90. Bailey doesn't exist today. It's ABB now, right? So in any event, there were some, I'll say, specific things about that DCS system that were interesting, right? It was all hardwired. All the I/O was hardwired. And what I just remember it like it was yesterday. What I remember most is the structured wiring was incredible, right? The guys who did the wiring were incredible at it. And it was a multi-pair cable, and there was a pair of cables that went to each I/O device, and they were all hardwired, right? And so in hardwiring, you would have to be on site to instill a cyber attack. And I think that's important to note. So today, I think one of the big differences that we see is like people plugging things into the IT network, right? And so that's critically important, and it becomes attackable if you do that, right? So in any event, that's what stood out to me as a technological change. But I would think about those things as they apply to not just cybersecurity, but certainly cybersecurity and I'll say the Industry 4.0, the industrial revolution that's happening right now with this business transformation that's going on in all industries. So the term Industry 4.0, it doesn't just mean like connecting a device to the internet, right? It means way more than that. And there are some advanced technologies that are being used in manufacturing facilities, like, for example, like digital twins and AI, artificial intelligence, right? High-speed wireless networks like 5G, for example, deterministic wired networks, cloud and edge computing. So the cloud is a very pervasive thing. Edge computing is a very pervasive thing, right? So there are a lot of manufacturing facilities that are leveraging those kind of things. Augmented reality and virtual reality, very common in today's world, in the world that we're seeing with this business transformation. So the other thing to note about the terminology, there was a joint working group formed between ISO and IEC, and they came up with the term smart manufacturing and to replace Industry 4.0. So what I personally see in the market, Industry 4.0 is used an incredible a lot. And there are very marked industrial revolutions that are occurring because of certain things, right? And right now it's technology, right? The advancements in technology are happening so fast that there are a lot of advancements in the manufacturing processes and those kind of things. So, but in any event, it's worth noting that smart manufacturing was chosen in lieu of Industry 4.0. So but to me, they're pretty This next slide, I want to call out a couple of things that are important to note, right? So productivity lost. This is a good stat, in my opinion, because there are a lot of manufacturing facilities that aren't employing technology. Most are, some aren't, but 5 to 20% is a projected amount of lost savings or productivity from not implementing technology to improve maintenance and those kind of things. So poor maintenance strategies are, lumped together to result in this, but 5 to 20% productivity found, 10 to 20% in energy savings if you are employing technology and data-driven decisions to manufacturing. 10 to 25% improvement in labor efficiency. So we're seeing these things today, right? So people are putting devices all over the place to do various different things, making real-time decisions, digital twins, getting involved in streaming analytics and those kind of things. So making real-time decisions based on actual data, right? Not just what we think is going on, but what's actually going on. And I think that's important. So this is a neat stat, I think. Percent of manufacturing companies that have digitized their processes, 82% of those companies are seeing increased operational efficiency. So, I mean, it speaks for itself, right? 82% is a very high percentage of companies are seeing operational efficiencies. About half of them are experiencing fewer product defects, right? So the quality equation, so increasing quality, almost half are seeing increased customer satisfaction. So I think that's a pretty good stat as well. Who's benefiting the most by IoT manufacturing? by a long shot, right? $3.7 trillion of benefit to manufacturing in general for installing advanced technologies and leveraging data driven decisions to make decisions. IoT manufacturing cost savings, 5 to 13% from an operating optimization standpoint. That's a lot. It can be a lot, right? 10 to 40% from a predictive maintenance standpoint. So, one of the things that we see the most being employed is predictive maintenance, right? Being able to predict when maintenance will be required and shut the line down, if you will, or whatever the manufacturing process is, but shut it down and do the maintenance and bring it back up in an orderly fashion. 10 to 40% from inventory optimization. What's popular today is real-time inventory, right? Nobody wants to keep inventory on hand. COVID, I think, kind of rekindled a little bit of thought around that specifically, as it was so hard in the supply chain to get goods and services, especially from the East, right? There was a shipping crisis. There were all kinds of challenges to get goods and services, but I think inventory optimization is a big piece of that. And real-time inventory is a real-time manufacturing is a reality today. Health and safety, 10 to 25% increase in that. Manufacturing was 30%. By the numbers, these stats are, I think, pretty staggering as well, but $50 billion of annual cost of unplanned downtime. $50 billion, that's a lot, man. Right. That's a lot. That's a lot of unplanned downtime. And you think of the number of manufacturing facilities that are out there, and maybe it's not such a staggering number from that perspective, but it's a pretty big number. 30% of U.S. manufacturing executives said their companies were planning to increase spending on IT in the next 12 months. I think that's a reality for all companies. $1.8 trillion of annual IoT cost savings for operations optimization achieved by manufacturing companies by 2025. It's a big number. Again, $1.8 trillion saved because of implementing advanced technologies and taking advantage of everything they have to offer. So $360 billion of the value achieved in 2025 by adopting IoT technologies will come from improved equipment maintenance. So that's number one, actually. Predictive maintenance is number one. Predictive maintenance has been around. Some of the things I didn't tell you about my background, but I started in process control, and predictive maintenance was around even then, right? So the 80s and early 90s or mid 90s, right up through the mid 90s, I was involved in process control, and it was a pretty interesting time for process control. But predictive maintenance was around then, so primarily used by rolling mills or any continuous process. Basically, try to optimize maintenance of devices, reciprocating devices, anything that rotated, right? Steam turbines or rolling mills or those kind of things. $350 billion of the value achieved is going to be predictive maintenance. It's a big number. 50% reduction in downtime due to using real-time data to predict and prevent. It's a big number. 50% of downtime prevented. So what's driving smart manufacturing? Well, it's data-driven intelligence, quite honestly, and there are a lot of different ways to leverage real-time data. And I think it's important to note that that's a viable driver of smart manufacturing. And it's all about the data, in other words, and leveraging technologies, smart technologies to drive outcomes, right? So what outcomes are we seeing? That these are often termed like benefits, right? So the outcomes that we're seeing are in improvements in quality, cycle time. Cycle time is the amount of time it would take to output a product, right? So we're seeing improvements in quality, cycle time, efficiencies, energy, less energy required, less capital expenditure, less raw materials. Very, very good outcomes, I would say, from a smart manufacturing standpoint. Okay, so the technologies that we see most often involved in Industry 4.0 or smart manufacturing, and I'm going to go through these. There are 17 of them. 3D printing. We all know what 3D printing is, and 3D printing is becoming smarter, right? And the devices leveraged in 3D printing are becoming smarter, and people are making more and more things from 3D printers. 5G technologies, we've all heard of 5G, and it's really having an impact, that connectedness, right? So the bandwidth of 5G is just phenomenal, and having 5G available to do things with is one of the advancements that we're seeing. AI is in every industry, it's all over the board, right? So we see a lot of AI happening, but if you think about like making intelligent decisions, AI is generally a part of that. So, and AI is all about leveraging mass quantities of data to help make decisions. And so we see a lot of that going on now, in data-driven decision making. It's a very important thing in predictive analytics. That's a part of AI. And anyway, it's I see AI as being a big part of the revolution, the Industry 4.0 revolution. Augmented reality. From a maintenance standpoint, we see a lot of this, right? So in a manufacturing facility, if there's a machine, generally the maintenance people are probably, seeing the repair as they do it or before they do it, or whatever the case may be. Virtual reality, we see here in augmented reality. Automated guided vehicles, that's a pretty hot topic these days. And there are some companies that are, really moving forward with this. And the autonomous vehicle perspective, there are some cities that are using autonomous vehicles today, and we see a lot of autonomous vehicles taking pictures and various different things, right? So blockchain technology, I don't know how familiar everybody is with blockchain, but it's a big thing. And just, I'll say it was in the hype cycle, in the midst of the hype cycle for a while, and people have backed off a little bit because AI is so pervasive now with ChatGPT, right? So, but blockchain is still a viable technology, and a lot of people are building solutions on blockchain right now. And security and blockchain go hand in hand, and people are pitching how secure blockchain is and those kind of things. So, but basically it's exactly what it says. It's a chain of blocks, right? So like block number one has to know what block number two, the decisions that block number two makes in order to be viable, right? So it becomes 1 + 2, 1 + 2 + 3, 1 + 2 + 3 + 4, and those kind of things. But in any event, blockchain is being used for anything that needs to be secure and those type of things. Cloud, cobot, cybersecurity. We see a lot of that happening now. Digital twins. The digital twin technology has been around for about 10 years, but it's really moving up the food chain and the value chain now, and people are taking advantage of multiple sources of information. Sorry about that. Making decisions in real time is very conducive of digital twin technology and those kind of things. So drones, we're seeing all over the place, right? People are flying drones for military exercises, to remove bees' nests from houses, all kinds of stuff, right? So to take pictures of fields or houses or those kind of things, but a lot of drone technology, edge computing. So this becomes very interesting from an edge computing standpoint, because a lot of manufacturing facilities, they don't want their data on the internet, right? So they keep it locally. And there's a push for, I'll say, edge computing to keep data local. But there's also edge computing in general means either getting closer to the customers or getting closer to the data, right? The source of the data. And but edge computing can mean isolating the data, right? So not putting it on the public cloud and those kind of things, connecting it to the internet and various different things. So privacy and intellectual property protection and those kind of things, edge computing is can be used a lot for that as well. IoT devices, we're going to talk about that a lot, and the platforms, associated platforms, but most of the cloud providers have technology stacks that are dedicated or applicable to IoT and those kind of things. Quantum computing, this is a big one because I'll say it's a little bit early, but we're seeing quantum computers now, and the quantum computing becomes interesting because computers can accomplish a lot in a little bit of time. And the quantum computers that we're seeing out there now, they're manufactured by, like, IBM, for example, puts out a quantum computer, and quantum computers are known for encryption, cracking encryption, and doing various different things. But I'll say the AI suite and a lot of the technologies that you see on this list are made more efficient with quantum computing, right? So machine vision and virtual reality. So what are the cybersecurity considerations as it relates to Industry 4.0 or smart manufacturing? And I think a lot of things come into play, and I wanted to start with the equation most known for risk, right? So anybody in cybersecurity knows this equation: risk equals a likelihood times impact. And I'll say it's pretty pervasive, but a lot of people are questioning, like, how likely is a security incident going to happen, right? And so a lot of people are questioning the likelihood variable in this equation, right? So in so doing, we've come up with a modified equation, right? So likelihood, if you break it down, it's the threat times the vulnerability. So there has to be a vulnerability and there has to be a threat. Threat is generally exploiting a vulnerability. So is the vulnerability already exploitable? Maybe, maybe not, right? So if it is exploitable, it has a higher risk. If it's not exploitable, it has a lower risk. And so breaking likelihood down to threat times vulnerability is better. This equation, this is my favorite one, actually. It says to have likelihood can be determined by means plus motive, right? So you have to have a motive and you have to have a means. So I think when you think about that, it makes sense, right? So you have to have a mechanism for doing something, an attack, and you have to have a motive for doing attack. Like, if you don't, like, what's the point, right? Why would you even do it? And you have to have an opportunity for the attack. So, and that's multiplicative, right? So the opportunity you could look at, like the vulnerability, right? The means and the motive, blah, blah, blah. The business impact, we always see as part of the equation, right? But what I like most about this equation is it's inversely proportional to the controls. And I've always questioned, like, some people spend a lot of money on security, some people don't spend any money on security, right? And the spectrum ranges, somewhere in between there. There are other companies that, spend a moderate amount of money or spend a lot of money relatively. But in any event, the controls are inversely proportional to the risk. So the more controls you put in place, theoretically, at least, the more controls you put in place, the less risk you have. And I think that's easier to get our minds around, right? But what it equates to for me is people are spending money on cyber security, and controls are less risky, right? So if you make the investment in a control, and a control is like endpoint security, like antivirus or anti-malware, right? So if you invest in that technology, you should be rewarded somehow. And I think you are rewarded because the risk is going to come down, right? So in any event, I wanted to really point out the difference in risk equations as it relates to that. So IoT devices, the install base, this stat is for all industries around the world, and it's from 2015 to 2025. That's a 10-year span. So what we see is like almost five times as many devices in a 10-year time period. That's a lot, right? 75 billion devices by 2025, right? In 2023, 51 billion devices. There's a lot of IoT devices out there. There are a lot of IoT devices out there. And I think the number is going to increase, and it's going to increase quickly. So the good news in this graphic is that the number of devices is basically the same, right? So, but what's most interesting to me is that the major challenges in IoT technology, and we see IoT technology happening all over the place, right? In healthcare, we see a lot of IoT devices. It's called MIoT. In industry, we see a lot of IoT devices. It's called industrial IoT or IIoT, right? And there is a term called XIoT to encompass basically all of the devices at the same time. So that includes OT devices and IoT devices. But what are the major challenges? Developers who are rushing IoT products that are not properly secured. 85% of the devices that are out there are subject to that, right? So we see this all the time, right? People are rushing devices out there. They're rushing to get startups to enter the market and start marketing those products. And we see cybersecurity comes last in a lot of cases, and in some cases doesn't even exist, as we'll see, right? IoT products on the market that are vulnerable to attacks, 70%. So this is a very interesting 70% of devices currently on the market are vulnerable to attacks. So if we think about it, 70% of 51 billion devices is 35.8 billion devices. And that's a lot, man. I think about 36 billion devices are, vulnerable to attack. That's a lot. By 2025, so 70% of 75 billion devices is, 52.8 billion devices. It's a lot. It's a big number. So this other stat I thought was pretty interesting as well. So the number of Americans who never update their firmware, right? It's like it's set it and forget it, right? But if you think about updating firmware, it's very difficult because you would have to take a line down, or you would have to take, you would have to take the device out of service, do the update, and then put it back into service. And so it's difficult, but 60% of Americans never update their firmware. So we're seeing devices that have been out there for years, right? That maybe don't even have cybersecurity. But from a patching perspective, like an updating perspective, the devices never get updated. So anyway, a quick story, right? So I did a risk assessment I was personally involved in this. So I'll say we did a risk assessment on a manufacturing facility one time, and the control room, the door wasn't locked. It clearly wasn't used anymore, right? There were like, I don't know, 3 inches of dust on pretty much everything, but there was one light on in the whole control room. And my question was like, there's a light, what is that? And the guys that were with us on the tour, they said, nobody knows. And that's why they're not shutting it off, right? But that's so conducive of manufacturing facilities today, right? There are sometimes outdated or old control rooms in play and control devices and such. And a lot of them are still running. I'll say some of them are running outdated OSs, quite honestly, like Windows 98 or Windows 95 even, right? So, but in any event, that I thought that story was pretty conducive to. So the size of the internet IoT security market worldwide from 2016 to 2025. Currently, we're in 2023, $22 billion. Projected to be in 2025, $31 billion. So it's a big market. That's I thought this was interesting because it talks a lot about the security threats and concerns worldwide. And I'll say the top three on this there are about 1/3, right? So if you think about attacks on IoT devices, it may impact critical operations. So the critical infrastructure, certainly of our nation, is a laser focus of the government. And we saw all kinds of things like executive orders that came through in May of 2021, Executive Order 14028 or 14028 came down the pipe, and it included things like zero trust, S-bombs, and various different things like that. So we're seeing a lot of that stuff applied to critical infrastructure, and this is why, I think, right? Lack of skilled personnel to implement IoT security. There's no question. There's a lack of security personnel around the globe, and it's a pretty pervasive problem, quite honestly. So almost 1/3 of the people thought that was, number two, protecting sensitive data generated by an IoT device. So, this is a huge problem in not just the U.S. but around the world, right? So the devices generate data, and that data becomes vulnerable. And the devices a lot of times are vulnerable. So it's a big problem. And we'll send out this slide deck so that you can review all of these things. From an OT standpoint, ICS cybersecurity. So SANS is an organization that we're probably all familiar with. SANS says, hey, look, ICS security, OT security is moving up the food chain. It's becoming a very common attack vector. And they say that most organizations are not prepared for an OT or an ICS cyber attack. And that's probably true. But they're saying in this article that a lot of people are, but it's because of the high profile incidents that happened in 2021. So does anybody know what they're talking about in 2021? What happened? Colonial Pipeline and JBS meatpacking facility. And they're both critical infrastructure companies. So the Colonial Pipeline incident, these were both IT incidents, right? So it wasn't really an OT cyber incident. It happened on the IT network, and they shut down the OT network because they didn't know what else to do, right? So just shut down operations. But in any event, the very high profile events, I think we've all heard of all of these events, but Colonial Pipeline is the pipeline from, I think, Texas to the East Coast. And it carries gasoline from the refineries to the East Coast. And there were gas lines that were happening because of it. And a lot of gas stations ran out of fuel, right? They didn't have enough fuel. And a lot of airlines ran out of fuel. A lot of things that get fuel from those pipelines ran out of fuel. And it was a huge problem. JBS is critical infrastructure because it's food, right? So there were food processing facilities that were shut down as a result of that. So anyway, it was, how do you achieve like maximum bang for your buck today? Like, how do you achieve maximum bang for your buck and lower your risk? So number one on my list, and this is a personal opinion thing, this is in my opinion, but I think it's pretty true. right? We hear it all the time, right? So number one is to identify the devices that are connected to your network or that are on your network. And most commercially available systems that do this do it by observing the network traffic. It's called network traffic analysis. So you would observe the packets or the network traffic, and you say, hey, that looks like a printer, or that looks like a pressure transmitter, for example. But in any event, there are devices out there that identify the devices that are controlled to your network. And one of the problems that I see a lot, and I've had like enterprise manufacturing companies, publicly traded manufacturing companies, come to me and say, people are plugging things into our network that we don't know about, right? Or IT doesn't know about. And that happens all the time. Probably more than we care to admit or even know about, right? So it happens all the time. And I think that's step number one, right? If you don't know about it, you can't protect it, right? So you have to know about it first. And the second item is identify the vulnerabilities on those devices, right? So now you have a list. It's really an asset list, right? So you have an asset inventory or a list of the devices that are connected to your network. The second piece is identifying the vulnerabilities on those devices. And that can be a little bit harder. There are some scanners like that, that say that they're good scanners for OT devices and IoT devices and basically any device. It's questionable like how good these scanners are, but we pretty much have to believe these people. So you may already have an enterprise class network scanner that's qualified to do OT devices and those kind of things, but identifying the vulnerabilities on them. And there are several different attack surfaces on an IoT device, like hardware, firmware, network interfaces, network connections or wireless connections, connectivity. And a lot of times they port their data to a cloud-based app, right? So being able to pen test the cloud-based app is important too. And the third thing is fix the vulnerabilities that you find, right? So I'll say fixing vulnerabilities is only a part of it, right? So I think first you have to prioritize vulnerabilities. So, and what I always use as a metaphor for this is like if you have a Windows 2003 box that's not connected to the outside world, right? It's not exploitable. So it therefore carries a lower risk. And if you have a Windows 2003 server that is exposed to the outside world, therefore exploitable, it has a higher risk, right? So I think the public databases for vulnerabilities, they would rate them the same, right? It's a critical vulnerability. If you have an outdoor dated OS on any device, anytime, and I think leveraging risk-based vulnerability management is important, and we would use that to prioritize the vulnerabilities, because most of the time, like we don't have enough resources to remediate thousands of vulnerabilities all the time, right? So we have to prioritize, and the most risky vulnerability should have a higher priority and should be remediated first. But one of the things we always say at ASMGi is you don't lower your risk when you know you have a vulnerability. You lower your risk when you fix it. And I think that's an important saying, because just like identifying the vulnerabilities is only part of the equation. And then you have to prioritize them and you have to fix them. And this is pretty much a constant, right? You're always fixing vulnerabilities, in my opinion. So how important is identifying vulnerabilities at the device level? Very important. It's very important, right? So, and the reason it's so important is because what we see a lot of devices, like 60% of them, are not using encryption when downloading their software updates, right? So they just download software updates and don't use any encryption. Some of them don't encrypt transmissions at all, and that's risky, right? Cross-site scripting or other flaws in web interfaces. So most devices today have a web interface and or are connected to the outside world, and that makes the risk go up. But certainly cross-site scripting being a part of these web interfaces, very, very big problem. Raise privacy concerns over the amount of data they collect. So there are a lot of devices that are collecting data. We don't even know what data in many cases, right? The devices are collecting data, and we're saying, hey, I'll say in general, we're saying there's some value in the data. We don't know what it is yet. So we will figure it out later. We'll just collect it all today. So I think it's important to do that and allow the use of weak passwords. We see this as a big problem on legacy devices. And most modern devices, or most devices that are coming out today, have strong passwords in them. But a lot of legacy devices have weak passwords or no password at all, right? So there's a field for entering a password, but a lot of times it's left blank, or the password is weak, or the password is password, or the password is published on the internet, right? So big problems. What's the benefit of knowing the vulnerabilities in firmware? I'll say this is one of the areas that we see moving up the food chain, or value chain, if you want to think of it that way. But firmware exploits, first of all, this makes sense because people weren't even looking for firmware updates 10 years ago. Today, they're looking for firmware updates and vulnerabilities and those kind of things. So it makes sense that they're finding more because they're looking more, right? But they're also finding more because they exist. And I think it's important to note that. So I think it's important. The point I always make is, like, a traditional application and firmware, they're not two different things. They have the same software development lifecycle. They have the same process, right? And so you can flesh out vulnerabilities in both of those environments equally as well, and leverage change management to issue the vulnerability fix into the change management database and fix it. So I'll say the software development lifecycle for firmware, it's probably the same as the software development lifecycle for traditional applications. The firmware might be written in a different language, different level of code, if you will, but it's the same. The software, the SDLC is the same. And I think it's important to note that. So questions, who's got questions? Got a couple in here. We'll go through. Okay, one question I have. You mentioned attack surface. What do you see as the greatest threat moving forward from an attack surface perspective? That's a great question. So personally, in IMO, right, in my opinion, I see IoT devices and software really moving up the food chain a lot. And if you think from a bad guy's perspective, it makes great sense, right? So it's no controls versus a lot of controls, right? So people aren't going to attack endpoints or the IT network. They're going to look for places that don't have as many controls. And I'll say OT devices and IoT devices, that a lot of them don't have controls, right? So we're seeing IoT devices implement cybersecurity, sometimes regulated, federally regulated, that they have to implement cybersecurity. And software is another area that I see, software / firmware, but I see a lot of that exploit or exploitation in that area happening. So software, we talk all the time about software supply chain There have been attacks like SolarWinds, for example, was a software supply chain attack, right? So people attacking the software company and making the updates contain malware and those kind of things. So companies connect to the software company legitimately and download the update, right, and install it. But if it has malware in it, it's a problem. So I see IoT devices and software / firmware being the areas most affected by that. Okay. How best to identify vulnerabilities in IoT devices? So what I would say to this question is, it's a great question, and there are basically 5 different attack vectors in IoT devices. One is the hardware, the firmware that lives on the IoT device, the network, wireless connections or interfaces, right? So like Bluetooth or wireless connections, and the cloud / web interface or the cloud-based app. So of those 5 areas, that I'll say a pen test is probably the best suited way to identify vulnerabilities, but there are various different mechanisms for identifying vulnerabilities. ISA IEC 62443 is a great standard for certifying that a device is secure. And it looks at all kinds of things about your organization to be able to establish that. Like, do you have a SPDF or a secure product development framework in place, right? So are the processes that you use to develop the product secure? And if they are, then probably the device is secure. And I think, that's a great mechanism for establishing if you have secure devices. But I would say from an attack vector standpoint, you need to pen test all of these things, right? The device, the network interfaces, the cloud-based application, all of those things need to be pen tested. Can you name some packages to identify devices in the network? That's a great question, right? So I would translate this as what packages do I know are available to identify devices that are connected to the network? And I literally I've had manufacturing companies tell me a lot, like people are plugging in virtual reality machines or augmented reality machines or cameras. Cameras are a good use case, right? So cameras used to be on coaxial cable, right? Closed circuit TV. There used to be a network specific to the cameras that shine on parking lots and or manufacturers' doors, those kind of things, right? But it used to be all coaxial cable, and today it's Ethernet cable, right? And they plug into a switch support. They plug into the network, and that's what collects all the pictures and that people look at, right? So cameras are very insecure devices, and a lot of the, I'll say, remediation that we've done or the exploitation that we find is on cameras, right? Or the exploits that we find is on cameras. So can you name some packages to identify? Clarity is probably the most popular in manufacturing. They have a medical arm. I think through acquisition, right? They acquired a company called Medigate, which is the most popular as well. Armis is another one that identifies devices on the network. Order has a medical device, but they're moving into manufacturing as well. And they probably already have moved into manufacturing. So they're identifying devices on the network. So I would say those 3 things are probably most popular from that perspective. What are the key cybersecurity risks and threats faced by manufacturing industry? Yeah, I would say risks and threats associated with IoT devices and software are what we're seeing most pervasively. So how can manufacturers protect their intellectual property and sensitive data from cyber attacks? This is a big thing, right? So nation states we know are after intellectual property, and like they attack China, for example, attacks manufacturing facilities to steal their intellectual property and remanufacture goods and services at a lower cost. So how can manufacturers protect their intellectual property and sensitive data from cyber attacks? I mean, this put controls in place. I think the number one thing is like pick a framework, and you probably already have a framework. So NIST, I see, is making putting a lot of effort into developing frameworks, but the NIST cybersecurity framework is pretty good, and ISO 27001 is pretty good. So but I would say rally behind a framework, and maybe you have a regulatory requirement that you have to meet a certain compliance requirement or set of regulations. Implement that. That would be recommended, right? To implement the regulatory requirements first, but meet those and just follow a framework, right? Most frameworks tell you what controls need to be put in place, and ISO, is a good framework in my opinion, because it talks about having an organization that's security centric and those kind of things. And the ISA IEC 62443 standard, I would leverage that from a device standpoint. Anyway, that's my thoughts. Oops. How can manufacturers effectively train and educate their employees about cybersecurity, create a culture of awareness and proactive defense? This is a great question. We actually have a webinar coming up. I think it's on September 13th or 14th. I probably have the date in a slide, but the talking about security awareness training, but security awareness training has been around forever, right? We used to build custom training modules. We used to always build them in PowerPoints, and they took like an hour, and nobody does that. Nobody's has an attention span long enough to spend an hour on security awareness training. So I think what's popular today is quick hitting videos and relevant topics. I think it's important to do both of those. But what you want to do is create a culture of security within your organization, and a culture of security basically means, like our organization, we get spammed all the time, right? So everybody in our organization knows exactly what to do if we get spammed, and everybody knows what to look for, right? So the best example I have is like our controller got an email one time, and it asked, to change an account. We hear countless stories about people changing accounts and sending money to the bad guys, right? But she looked at the email, and the email address was Gmail, right? Nobody would send an email address would send an email on a Gmail account and for company business, right? So she knew what to look for. But I think it's important to be aware of that and to create a culture of security in your organization. So I want to just get to a couple other things, and I think we're running out of time. So special offer today for attendees of this webinar. So that will get you an SBOM if you want. It can be a firmware or traditional software or whatever, but we'll get you an SBOM, and we're very adept at making those. I'll say there are a couple of different formats that are relevant. So the SPX format it's ISO certified, and it's a good format. The Cyclone DX format is what OWASP uses. I'll say, but it's pretty lightweight in general. So SPDX is probably the preferred format, but just send me an email and tell me you want an SBOM, and we're happy to, create one for you. So in any format that you want, but probably an SPDX format. So, but I wanted to make that out there, and I want to communicate. So upcoming events at ASMGi, I sit on the board for ISA, which is the International Society of Automation. We do a lot in that organization, and I'll talk a little bit about the Information Security Summit coming up in Cleveland, Ohio in October of this year, but we do a lot from the ISA section and district level events. I also sit on the board for the Third Party Risk Institute. It's a Toronto, Canada organization. I think it's really good, and manufacturing has a lot of third-party vendors in play. A lot of the technologies that you're implementing are developed at a third party, and third-party risk is also moving up the food chain. Like the financial services sector have requirements about third-party and nth-party risk and those kind of things. I think it's applying to a lot of industries. Now, security awareness training webinar, September 13th. I don't know what I said before, but we have a security awareness training webinar coming up in September on the 13th. We also have FDA either coming to Cleveland for a physical event, or we'll do a webinar with them. But the FDA is putting some of these cybersecurity regulations in play, and I think this is something that we'll see across the board. ICS for ICS. So we have them coming to the Security Summit in October. The dates are on here. It's in Cleveland, Ohio. October 23rd, ICS for ICS is coming, and we're doing a 4-hour training session with ICS for ICS. What ICS for ICS does, it's a FEMA-based system that it's a combination between the Department of Homeland Security and FEMA, but it's incident command system for industrial control systems. And I think it's appropriate for doing an incident response plan and activity, right? So the training session is going to teach you how to do this. And I think this will be a great event, but it's going to be held at the Information Security Summit on Monday, the October 23rd. Speaking of the summit, so we have that training. We also have DevSecOps training the following day. On Tuesday, the 24th of October, we have 4 hours of DevSecOps training. So we'll teach you how to, create secure software. And we also have a breakfast briefing from ISA coming up on, I think that's Thursday morning. It's on IT/OT convergence. So there are a lot of topics that can be covered as part of IT/OT convergence. And, this is one of them, like plugging devices into the IT network. It's a very common practice, and a lot of things happen. So I told you a little story about, installing a Bailey Net 90 system and those kind of things. One of the interesting things to me is, like, it used to be all proprietary, right? The processors were all local, truly air-gapped system, right there. The processors were all local. And today, DCSs run on Windows servers, quite honestly. So they have to be patched and all of those things. So it's interesting. And then we have multiple sessions throughout the summit. I think we have one on Thursday, one on Friday, I'm pretty sure. So third-party risk management is on Thursday. That would be the 26th of October, and DevSecOps is on Friday, the 27th of October. Closing remarks, I would say, closing remarks are basically this. We see device level security really moving up the food chain, and IoT devices, 75 billion by 2025. There are a lot of devices around the world, and legacy devices are basically not secure, right? So people are putting in controls now, and I'll say from an OT standpoint and an IoT standpoint, people are really focused on securing that part of the network. And I think we're going to see more attacks on those networks than ever before in the next few years. So that's all I have. We're over on time. I appreciate you, coming, and appreciate you sticking around. So thank you all. And if you want an SBOM, just send me a note and we'll get you one, and we'll talk about like how best to accomplish that. So see you later on. Thanks. Cheers.